It's the last section of the introduction to the Gephi software and information visualization with the Gephi software workshop. Here we want to just explore more complicated graphs in terms of the networks that have both nodes and edges, because in the two previous sections we just used a graph for the COVID-19 data set that just only included the nodes. But here we want to just use a graph which has the connectivity between the nodes and how we could extract more information based on the edges and what built-in filters are available in the Gephi software to extract, for example, the degree or some other information. So again, you could just find all the information about this section in our website, which I will send to you here. And then you could just follow this video and or follow the website to just create the materials or just follow the tutorial here. So first I will just open the Gephi software as we had before. Again, just click on a new project, go to the data laboratory. I will just move on a little bit more faster here because we just went through these sections before. Click on the spread datasheet and go to the one place that you just saved the files nodes1, edges1. So I'm just looking for first loading the nodes. So the nodes1.csv is the file that contains the nodes here. As I said, it's a semicolon separator format. It's again in the CSV file. And these are the nodes. So make sure you just load them as node tables. And this is more important in comparison to two previous sections because in this section, besides the nodes, we have edges. So make sure you import this file as the nodes table. Just click on next and make sure the attribute 1 is set to the integer, city is set to the string, latitude and longitude are set to the double. So those are the configuration that we want to have. And let's click on finish. So it says we have 1,000 of nodes and click on OK. So it just import the nodes for us. Again, click on the import a spreadsheet. So we want to just import the edges besides nodes. So just look for the edges1.csv file. Edges1.csv file shown here. So that's the one that we want to show what's the connectivity between these nodes. Click on open. It just identified as the edges table and it's directed. Click on next. Make sure the weight is called the double because there are some weights attributed to the edges, and click on finish. So this graph has 1,000 of nodes and about 40,000 of edges. And click on OK. And if you go to the click on overview, you could see the graph. And in comparison to the two previous sections, this graph complexity is really high and it's extremely difficult, or we could say it's impossible to extract information without rearranging and putting some colors or changing the size of the nodes and the edges. This graph also represent the longitude and attitude of cities across the Europe, but here we want to choose different layout or the rearrangement technique. One of the most common rearrangement technique is called the Force Atlas 2. So go to the layout, choose layout, and Force Atlas 2. click on Force Atlas 2, and it tries to open up or cluster the data based on the degree of the graph, which means it just cluster uh, the data between based on the connectivity of the nodes, and the scaling parameter just scales your distance between the nodes. So the higher values of the scale, which lead to the wider scale of the graph, final graph, but the lower number just shows the smaller distance. So I will start with the 100, and I just let the graph to be converged and make sure just not choosing the gravity. Also, by choosing the gravity, you could just change uh, the attraction force between the nodes. So let's see if we choose free. So it seems it doesn't have a really strong effect on the graph. One of the most useful information is to say prevent overlap to make it better to prevent the overlap of the nodes. It seems that 100 is not really enough here. So no, I will just make it back, bring it back, and that's it. So now we could put some colors on the nodes based on the degree. It seems the distribution again is not okay. So that's a better distribution here by just choosing the one at the exponential one. And we want to just increase the size here. So let's just put a constant size but make it bigger. So it seems that's too big. That's also too big. So I will just choose 150. And I could now click on the edges, because besides, in comparison to the previous section that just we worked on the graphs that only contained nodes, we have some edges as well here, and we could change the color of the edges based on the weight. And the color of the edges also is not distributed linearly, so let's to change that. So that's the color of the edges. Now we could extract some more advanced statistic information. For example, we could just run the average degree to just take the average of the degree in the graph. For example, just run it. It would just give you the degree distribution, and it says the average degree is 14, which means each node and on average has 14 connection with the surrounding nodes. So that's the distribution of the degree. Or we could just use the weighted degree because we have some weights for the uh, edges, and that would just says based on the weight the number is different here. We arrange this graph and we clustered. For example, we see a cluster here. We could identify at least 2 or 3 cluster because we have some cluster clearly cluster here, and we have 2 or 3 cluster here. So we could just run the network diameter to get an information about the diameter of the network. So graph that we have here, that would just tell us what's the diameter of this graph. So it just asks if this is a directed graph. So we say, okay, it's a directed graph, and it would just calculate that for us. And the diameter is 9. So that was for diameter of the graph. So we have some more information or more statistic. The other one, which is really useful, is to calculate the modularity of the graph. And for example, we could calculate that modularity, and it just identify, for example, because we wanted to just identify the clusters, and we identified near 3 clusters in our data, but more specifically or more quantitatively by using the modularity section of the Gephi softwares, we could identify that this graph or network has 6 clusters or 6 distinct clusters. So now we could come back to the nodes, go to the color, and use the modularity class and color the graph based on the modularity. So now you see that different uh, identified clusters here. So there is one cluster here, there is another one here, there is other one here, and so we identify 6 clusters in our data set. Now if we are fine with our graph visualization and extracted the information from the Gephi, we could again go to the preview section and choose the high quality rendering, and now we could save it to the PNG file. So let's just say graph, name it graph, and save it to the downloads as a PNG file, and I will just open that to see how it looks. So that's my final high quality rendering of this graph, which is shown here. The different clusters for the nodes, and we have some weights for the color of the edges. The edges, you could just change some other parameters. For example, you could change the opacity of the nodes or show the labels, or just change the edge thicknesses. For example, I could just make the thickness bigger and then again save the graph. So that one, just make the edges thicker. Or for example, make the graph, some nodes opaque, and also rescale the weights. That's it. So that's the final visualization that we got for this graph, and we just, for example, clustered this graph into 6 different regions and also extracted some statistical information. So that was just about creating the visualization of the graphs with the edges and how we could extract more statistical and advanced information about our graph, or do some clustering in the Gephi software and visualize that clustering. So that was just the last section of this introduction to Gephi software workshop. Thank you so much for your attention.